I think our dream is to really drive the cost down for cell therapy,
Make it
Be-
more accessible.
more accessible,
Yeah.
because it exists, it's transformative, and it really works. But nobody can afford $500,000, at least $500,000. It's not even. I don't think it's even reimbursable for. So it's not like it's not accessible, and so it cannot. So because of that accessibility problem, there is a social barrier into cell therapies, which means that only the wealthy can afford it. Then, so we want therapy developers to use our hardware on early R&D, and then bring it to manufacturing. If we have a therapy developer exclusively use our hardware or system and then successfully bring a therapy into approval, that's
That's the dream.
already good enough.
I'm your host Tayfun, and in this episode of Business as Unusual, I'm joined by Césaré Cejas. Césaré is co-founder of MFX, a deep tech company working at the intersection of microfluidics, cell and gene therapy, and advanced manufacturing, building the tools that could help make some of the most complex therapies scalable, reliable, and accessible. He comes from a strong academic background in physics, chemistry, and materials science, and today sits right at the crossroads of science, ethics, regulation, and entrepreneurship. Alongside building MFX, Césaré is also part of Foundation's Future Leaders program, contributing to discussions shaping the future of UK's science and technology ecosystem. So let's jump in and kick off Business as Unusual the way it's meant to be, with stories worth remembering. Hi, Césaré. Welcome to the
Tayfun.
show.
Thank you for having me.
Yeah, thanks for joining. We'll start with when people hear about cell therapy, it could mean millions of things. What does it really mean for people? So can you tell us a bit more?
Yes, so cell therapies are globally approved treatments. It's medical treatment, but essentially to replace a patient's damaged cells that their body is no longer able to regenerate. So, like for instance, if a person has leukemia and they don't respond well to conventional approaches such as radiation therapy or chemo, then cell therapy could be an option for them. How it works is that what's left of the patient's healthy cells are taken out of the body. It's cultured or expanded, grown outside of the body in a closed vessel, termed a bioreactor, that mimics the same conditions as the body. The cells are then genetically engineered, and with a synthetic receptor that when it's reinfused back to the patient, that will then help attack the cancerous cells, because every person we all have our immune system that fights off infection, and these are the white blood cells, or the T cells, but not the T cells cannot fight all of the infection, especially and when the patient is weakened by the disease or the cancer, then their immune system is no longer able to function that. So in a way, the cell therapy is sort of a boost to help fight off those cancerous cells. That synthetic receptor that is engineered will then target the cancerous cells. Now, there are different types of cell therapies.
But is it mainly being used for fighting against cancer?
It is the most common one, and the most licenses for therapies are for immunotherapy, basically CAR T, so blood cancers, mainly. Although there is now, I think there is growing.
Is it the main use case, like the blood?
Yes, it's a
cancers?
main
Yeah,
use case
main
because
use
it's
case.
I think it is the I wouldn't say the most prevalent, but it has been proven. And the origins of cell therapy came from blood cancer. I think when you talk to anyone in the industry, they would cite the story of Emily Whitehead, a young girl in 2010 who had acute lymphoblastic leukemia and had been told by doctors that she wasn't responding to radiation, and told her parents that that was probably the case. But she was enrolled to an experimental program at the Children's Hospital at UPenn, which was then the first one of the first, I would say, cell therapy trials for CAR T, and eventually, well, and now she's alive. She's still alive and well, and healthy. And that experimental program was then bought by Novartis.
Okay.
So that's why it's the most common. But there are other types of therapies in the market that are gaining traction, or probably there's more and more scientific evidence. Some examples would be like stem cell therapy. But I'll go into that later, because there are different types of stem cells, and people generally have a notion that when they think of stem cells, it's something that is morally ambiguous. But in general, when you talk about cell therapy, there are two types. You have autologous, which means that the source sample, the original patient cells, comes from the patient themselves, and then just re-injected back to the patient. Now, there's when you take something out of the body and then culture it ex vivo outside of the body, reinfuse it back, there's a chance that the body is going to reject it. That's normal. But because it comes from the patient cell, from the own patient cells, then the risk is lesser, but the risk is still there. The other type of cell therapy is allogenic, which means there's a third party donor that then donates the cells, and then it's reinfused back to the patient. But most of the licenses now for cell therapy in the UK, in Europe, in the US are autologous. And so for the foreseeable future, I think most of the therapy products will be autologous based, largely because of the higher risk with rejection from a third party, from allogenic cell therapy coming from a third party donor.
And how many years has this been technology exist? Like, how many years we've been using this technology?
So actually, I would say cell therapy has existed probably since the early 2010s.
Or 2010s.
And you have technologies out there for culturing cells to a clinical scale. That would say, in industry speak, we call it manufacturing scale up. You have the Miltani Prodigy, for instance. You have Lonza Cocoon. They exist, but these are large volume vessels, and it's good and they're appropriate for large scale manufacturing. By large scale, that means culturing cells up to at least a billion cells needed for a therapeutic dose. Now, it has existed, but not many people are aware of it because it's not accessible to many of us. The reason for that is because the cost for a therapeutic dose is $500,000. And certain people will need multiple doses. I mean, you and I, for instance, knock on wood, could have the same disease, but because our genetic makeup is different, I could need 4 doses. You could need just 2 doses. Depends how the body is reacting. But the reason it's costly because a large part of that comes from operations. When therapy developers first develop a therapy, they do an extensive R&D on how the cells react to this parameter, this change, or whatever. And then once they've done an extensive amount of experiments, they select the best one, the best condition, and then they translate that to clinical manufacturing. Now, often the problems now are that, one, that R&D is still largely manual. You'd be surprised to when you think about high school biology. If you try to recall high school biology, you try pipetting a lot of those liquid from one flask to another. That still largely happens, and cells sometimes some cells need regular feeds. When we talk to academic centers who first perform the cell therapy research, they have postdocs that come in at 2 a.m., 3 a.m. just to change the media for the cells. So that is largely manual. That adds up to overheads and operational costs. Next is that we don't have the comprehensive. There's a lack of comprehensive tools needed to understand what really goes on in the cell biology. We take samples, small samples, microliter samples, and put it in a different benchtop instrument platform. Takes out a readout data, but that's it. And there's also a problem of translatability. So when you do early R&D, you select the best parameter, and then when you go to clinical manufacturing, it's a different system. You're using a different, I would say, different instrument. You find out that it doesn't really translate. The process that you've optimized in that scale no longer works for manufacturing scale. So then there's a whole re-optimization process that needs to be done.
And what was the biggest milestone in terms of like cell therapy in the last maybe few years? In terms of like there's maybe a big jump in terms of technology or research, or is there a moment in the last maybe 5-10 years that changed the way cell therapy is offered to human?
Yeah, I think there's more and more technologies, to be honest. There are newer technologies that aim to improve this particular part of the process. For instance, when you do cell therapy, you need to genetically engineer, so inject what is referred to as a viral vector. There are technologies that kind of focus on that, for instance. So there are newer technologies, and there are more technologies out in the market that aim to improve how a therapy is being developed in the first companies.
So the main use case, like you mentioned, is cancer treatment.
Yeah.
Right. And this is in addition to traditional methods, not like as a replacement.
Yes, it's
right?
in addition.
In addition.
Yeah.
And in terms of prevention, is it being used as a prevention method, or is it more like treatment only?
For cell therapy in particular, it's being used as a treatment.
Yeah, as treatment,
I know in the industry there's probably talks around gene therapy. Now those are they're often combined together, cell and gene therapy, but in reality there are two different technologies.
Yeah.
With gene therapy, which involves genome editing, it's mostly to treat treatments for the moment, but there is discussion in the industry around how eventually to prevent that in the future. But that's, I would say, a whole other topic that involves largely ethics. The reason why cell therapy is not a replacement is because for the moment it functions well with blood cancers. Solid cancers, we're not there yet for solid cancers.
But there's a potential.
There is a potential,
Okay.
yes. There's a potential for solid cancers with stem cells, for instance. That's why you still have some radiation therapy. But some people do not respond well to radiation therapy.
Okay.
With chemo, for instance. And so the doctors will eventually assess what would be the right condition for the patient to be admitted to a cell therapy program.
Yeah. That's great. And what about your story? Like, how did you start? And you have academic background, professional background, so you're trying to merge academic as well as your professional background too. So can you tell us like who's Césaré really?
Well, I didn't actually start out in the cell therapy industry, but I did work in a scientific discipline that underpins a lot of these changes. So in the early 2010s, there was a movement scientifically to miniaturize soft systems. And by soft, I mean gels, polymers, work on droplets, minimizing fluids into what is referred to as microscales. And that is I think partly inspired by nature. Like for instance, if you it largely explains how trees are able to kind of transport water from the roots up to the leaves, for instance, or if you look at some insects, they're able to walk onto water, because there's a different phenomenon when there's a different physics phenomenon, a chemistry phenomenon when things are, I would say, decreased in a microscale. So I was in that scientifically. I was in that discipline, and that has then uh, uh, found applications in biology, kind of growing cells, because cells are flowing in veins and in arteries, which are also in that particular scale. So in a way, it's trying to mimic the conditions. It's trying to mimic the conditions of the body.
And I'm wondering about because there's this business side of it,
Yeah.
right? So you come from academic background, and how did you come up with the idea or the business model? And okay, so I can make a great business based on this.
So we talked to potential I would say early customers or potential customers that
And they are
basically develop
pharmaceutical
therapy. Yeah,
companies, yeah.
pharma companies, biotech, even academic professors who are in the cell therapy research. We try to understand what are their pain points currently that hinder them from developing a therapy, and they tell us what their problems are, and that's when we kind of we already in a way we already suspected that there was a market need somewhere, especially in early R&D, into helping reducing the cost of that therapy, with new generation hardware that has automation of a lot of the labor intensive tasks, like regular media feed, for instance, and then acquiring comprehensive data for this to understand the cell biology. But to get confirmation of that from our voice of customers, we interviewed collectively, I would say, more than 300 people across the different sectors, just to understand what's hindering them from developing the next therapy, and they tell us this and that, and that's when, okay, there is a market need in early R&D. We as a company, we are not touching the manufacturing scale up
Okay.
yet, because that's a different industry in itself. We are focusing on early R&D to try to streamline it, because like I mentioned, I would say 70% of a therapy cost is early R&D. And if all of that can be streamlined, then with then that would contribute to reducing the cost of a therapeutic. So our business model is basically like a printer. You buy the machine platform. You slot the single use consumable, and then the machine platform is the one that automates the media exchange, data acquisition, etc. What we're trying to do is, we're not trying to replace the skilled scientist, but with our platform, we're trying to free up the time for the skilled scientists to devote to use more of their time into analyzing the data.
Okay.
So now they're able, because the data acquisition is now in real time, which means while the culture is happening, then they're able to see a lot of the data, and they're able to have more information in front of them to decide what to do, what's happening with the cell biology, and what to do with the therapy. Now, with lots and lots of data, eventually, because the platform generates a lot of data, eventually the logical next step is to generate insights from that data. But that would be for
And do
later.
you use AI in any of during the process?
Not yet, but that's a logical
That would
next
be
step,
the next
because now the platform acquires a lot of data for pH in the media, O2, for instance, and then we're working on cell count and viability through imagery, and also kind of metabolites, which basically like glucose or lactate levels in cell culture. All of that data then all of that data is recorded. Plus, you have the metadata of what's the temperature, what's the pressure, when was it fed, at which time. Then when you have all of that data, you can envision AI or machine learning to to take some correlations on what on the state of the cell, on the state of the cell. So that is indeed a logical next step. But
Yeah.
yeah, that has
But is
kept
the
us going.
business profitable now, or do we still have long way to go
No,
before?
we're still considered pre-revenue.
Yeah.
We're still considered pre-revenue. We have some early revenues from our early access, from the sale of our consumable as on the in the early access program, because the way we've designed the consumable is that it can be used manually, but then you get the value add if you use the machine, our platform with it. No, we're still considered pre-revenue. Our next step as a company is to increase our commercial traction, because that's what investors want to see before they get involved with potential Series A discussions.
Yeah. And what needs to happen in order to get there? Like, is it more marketing, sales, or is it more proving that the device actually works?
Yeah. So the device works. I think what we need is more commercial traction. So in the sense that we need to expand our early access program. So basically, work with therapy developers during the early stage, of therapy development, have them test and validate the platform in real lab conditions, and get feedback out of it and see what works, what doesn't work, and if it really provides them.
And what's your dream with this company? Where do you want to get to? I mean, in terms of, do you have some targets in mind in terms of number of employees or revenue, or maybe seeing your equipment, the hardware being used in many research facilities or pharmaceutical companies? Do you have certain targets, and what would the dream look like? So can you tell me more about that?
I think our dream is to really drive the cost down for cell therapy.
Make it more accessible.
More accessible. Because it exists, it's transformative, and it really works. But nobody can afford $500,000. At least $500,000. It's not even, I don't think it's even reimbursable for so it's not like it's not accessible, so it cannot, so because of that accessibility problem, there is a social barrier into cell therapies, which means that only the wealthy can afford it. So we want therapy developers to use our hardware on early R&D, and then bring it to manufacturing. If we have a therapy developer exclusively use our hardware or system and then successfully bring a therapy into approval, that's already good enough. Because we can already, when we worked out the numbers, we need only a few. If we only need a few therapy developers to break even, therapy developers to exclusively use our system, because it's a single use consumable business model. So that's where the revenue largely lies. And a lot of consumables in biotech is single use.
What about the MBA? So, but by the way, we studied together at Judge Business School at Cambridge University with Césaré. And do you think completing MBA helped you with your business? Has it been transformative for you? So what do you think about that?
Yes, actually, multiple people have different reasons going to the MBA, but I knew what my reason was. I had a taste of kind of that business side when I did the Ignite program in 2017, and that was probably a year before I actually met my co-founder, and that's also what motivated me to kind of actually, I think I'd like to get into it, because otherwise, if I hadn't gone through that program, that would have been completely new. Like, I wouldn't have any idea. Now, I did academic research largely in my career, but yes, I also worked for Sanofi. But I felt that I had a very scientific mind, in a way, like like the way I think is very detailed. It's very detailed oriented. It's very logical. But I felt, for me personally, that I needed a formal education in business. People would tell me that some of it you learn on the job, which is true. There's value in that. You can get also some training on the job, and you can also get some small training here and there. But I felt that I needed a formal education. Partly, I would say, maybe to be taken seriously as a kind of quote unquote entrepreneur, or a someone in the business, as opposed to someone with just with a with an academic PhD.
Academic, yeah.
So I felt that was important for me. Now I've learned a lot for it, because when we did the MBA, the executive MBA, we were just starting out our early access program, and I think there are some lessons in there that I've incorporated immediately into the or I've helped incorporate immediately into applied into the company.
And what's your biggest mistake as an entrepreneur?
Well, let's see, that's a good one. um, I think for me, personally, for me, is not making certain decisions quick enough, and maybe also getting too emotional on certain decisions, when especially as a small company. Sometimes, yeah, business is business, and you have to make some logical decisions, but you can't help but also infuse a bit of emotion into it when you make tough decisions to the company. But in the end, in the end, we have to see the bigger picture on where where the company could go. There are some decisions not necessarily the company wants, but my personal decisions, that I think that took I would say took too time to linger in my head, and because of that, there's some that led to some consequences, which that I would have rather avoided.
I'm sure there are days it goes like, oh, nothing works, and you're very disappointed. And then, is there a way you overcome those moments? So what do you do?
Yes, it happens a lot in experimental R&D. I take a step back. We take a step back, and we kind of rein in. Okay, what's the data so far? What's it telling us? Sometimes we bring in an external set of eyes. It could be a consultant. It could be someone from the board or an advisor, to help us kind of try to make sense of the data. And then, okay, we try to then we okay, let's take the step, then plan out the next set of strategies step by step. Oftentimes that happens when we're trying to do too many things at once, and that we try to change this, and then sometimes we can't trace back, okay, what is causing this, so that happens a lot with R&D. I think majority of the companies who work in this space also have experienced that. Taking a step back, just looking at from kind of the big picture, getting an external set of eyes, whether that's an advisor or a consultant in the space, and then kind of helping us craft what would be the next step.
One final question: what's the definition of a life well lived, in your own words?
For me, it's when you're content with whatever it is that you've done. I'm a very competitive person, which means that I like to be better at what I do, if not the best. So when I feel like, good for this person, they've done this, and I don't feel that competitive spirit, I'm like, okay, I think I'm content with what I've done. But that in a way that also motivates me to do better at certain things. And I'm saying, okay, when I hear about new achievements here from others, I'm like, maybe I can try to do something better, and then okay, then I'll do it. But I think a life well lived is when you're content with the decisions that you've done, and you can justify them. I would say justify them, but you can explain them. You can argue that you made what is right for you, and you can live your life satisfied. Because one thing I don't like is knowing what could have been. That's the feeling that I probably dread the most. And it's okay, maybe I should have done this. Maybe I should have done this, because that regret, as a competitive person, that regret will eat me up. So, but if I'm content and satisfied with the actions that I've done previously, and I can explain them, I can argue, I can provide evidence, then I think yeah, that's a life well lived for me.
Is there any story that changed your life?
Yes, there is actually.
Okay. Okay.
Well, I
So
would say there is actually why I kind of veered towards quote unquote entrepreneurship, or kind of, okay, let's help build this company. Um, After I worked for Sanofi, I tried to apply for a permanent position as an academic, but it's very cutthroat. It's very cutthroat, and also highly political, I would say, uh, in some ways. Um, I had the support of another company, a big company, because I was the position was for an academic lab, but is hosted by a company in the south of France. And I think we, like, collectively, we were expecting that I would say, like, I would like I would yeah, that we would get it. I would say, because I had the back yeah, because yeah, I had the backing of the large company. I had a good project. And I think I'm fuzzy with the details, but I think we found out that the position wasn't even filled. None from anyone in that pool of candidates. So in a way, that kind of that I was really demotivated by the entire process, because that took a long preparing the application, applying for that permanent position. We apply for any university. When you apply for a permanent position, it's a painstaking process. I mean, when you apply it, so that, and then I said to myself, well, maybe I'll try again next time. Which happens. You're not expected to get it on the first on the first run. But and then eventually, I got the one of the results of my previous research. We filed a patent application on it, which then led me to the Ignite program in
okay,
Cambridge.
I see.
And then that's where, okay, actually, okay, and I understand what building a startup. I know I knew what building a startup meant in some ways, because during that time a lot of companies have already started sprouting up. But I never really understood what it took to actually help build one.
Okay.
And that was only when I did the summer program in Cambridge that, okay, actually, this is what needs to be done, if ever. And so when I was faced with that decision later on, that, okay, should I do this? Should I do this? Then it was an easy decision to make, because now I've all of that chain of events led me to, yeah, making that decision.
Great. Cesare, thanks very much
No, thank you for
being
having me.
here.
Hopefully I wasn't
Really
rambling on
enjoyed
it.
the conversation. Thank you.
Thank you.